For the next slide, if maintenance costs will affect to the industry or company. For the last slide of my part, it is about theory fault diagnosis. Okay, for the first point is fault diagnosis can be defined as a method to determining which fault occurred. In other words, determining the roots of the out of control status. Okay, the methods can be categorized into data driven, analytical, and knowledge based approaches. Okay, meaning of out of control status, that is when points on a control chart move outside the upper or lower control limit, the process is said to be out of control. Okay, for the second point is process fault diagnosis includes interpreting or implementing the current status of the plant given sensor readings and process knowledge. That means fault diagnosis based on historic data models has received increasing attention in the last decade. Okay, for the third point is the different types of faults that are observed in these areas and the methods of their diagnosis are accordingly great, including vibration analysis, model-based techniques, and statistical analysis. Model-based approach involves the establishment of a suitable process model, either mathematical or signal-based, which can estimate and predict process parameters and variables. Okay, for the last point of the slide, it is fault diagnosis is vast and wide-ranging, encompassing such areas as general surveys, general system modeling, and also methods applied to the fault detection and isolation (FDI) of specific items of machinery such as that found in land and marine-based power plant and in aero engines. Example of FDI techniques can be applied in different situations, including both static and dynamic process. That's all for my presentation slide of my part. Thank you.
Assalamualaikum. My name is Muhammad Azizul Hakim bin Azizi. I would like to present about the machine condition monitoring and fault diagnosis on shaft. Condition monitoring is the process of monitoring a parameter of condition in machinery such as vibration, temperature, and many other in order to identify a significant change which is indicate of developed fault. It is a major component of predictive maintenance. The use of condition monitoring allows maintenance to be scheduled or other action to be taken to prevent consequential damages and avoid its consequences. Condition monitoring has a unique benefit in that conditions that would shorten normal lifespan can be addressed before they develop into a major failure. Condition monitoring techniques are normally used on rotating equipment, auxiliary system, and other machinery such as compressor, pump, electric motor, internal combustion engine, and many others, while periodic inspection using NDT non-destructive testing technique and fit for service FFS evaluation are used for static plant equipment such as steam boiler, piping, and heat exchanger. condition monitoring technology. This the list that include the main condition monitoring technique applied in the industrial and transportation sectors. The first one is condition monitoring overview. Then vibration analysis and diagnostic, lubricant analysis, acoustic emission, infrared thermography, ultrasound, oil condition sensor, motor condition monitoring and motor current signature analysis, model-based voltage and current system, and the last one is most CM technology are being standardized by ISO and ASTM. Machine fault diagnostic. Machine fault diagnosis is a field of mechanical engineering concerned with finding faults arising in machine. It is a process to define faulty on the machine. Process fault diagnosis involves interpreting the current status of the plant given sensor readings and process knowledge. The most commonly used method for rotating machine is vibration analysis. When talk about the rotating machine, it is commonly related to a rotating shaft. Normally vibrates of a machine is because of unbalanced shaft rotating, misalignment of coupling between shaft, and defect because of the material defects. That's all from me. Thank you.
My name is Muhammad Izzat bin Mazlan. Phase angle measurement. Phase measurements are used to assess the relationship between two vibration signals. It is commonly used in machine balancing and advanced diagnosis of machinery fit with proximity probes. Phase information is taken in the time domain, carrying out of a FFT of a time waveform loses the phase information. Phase angle is the timing relationship between two signals of identical frequency. Phase is normally measured in degrees and can be either relative or absolute. Relative phase requires two vibration signals of the same frequency. Absolute phase requires a vibration signal and a synchronized reference pulse, example, key phasor or optical tachometer. Uses of phase angle measurement. Example of how phase angle measurement can be used. Shaft balancing. Vibration measurements are related to the phase reference to calculate the placement of balance weight. Shaft crack detection. Shaft or structure resonance detection. Shaft mode shape. Direction of shaft precision. Confirming force or couple imbalance. Confirming misalignment. Shaft orbit. When two XY vibration signals are added together, the resultant signal shows a two-dimensional picture of the vibration motion. There is known as an orbit. If the two vibration signals are from casing-mounted transducer, example, accelerometer, the orbit reveals the casing motion. If the two vibration signals are from proximity probes, the orbit reveals the actual shaft motion with the bearing clearance.